Hi guys, today we're going to do a physics simulation using JBox 2D physics engine, which is now integrated into FXGL. And what we have now is this application, which is just a test of physics and physics entities, so how things operate with a more or less physically correct environment. So this is more of a sort of developer preview test rather than actual tutorial, but this will sort of give you an idea of how things will go in the future and how you can create physics entities with FXGL 0.1.2, which is the latest version. So what we have now is you'll need to add this library to the build path of your IDE, and the link will be in the description. And we haven't done asset loading for a while, so in this tutorial we'll do a sort of ball asset. It is just a sprite I downloaded from the internet and just copied over to your assets.textures. It has to be under source, and then the package name must be assets.textures so that FXGL can find it. And just place the ball texture in there and make sure you rename it correctly so that you can use just remember the name of the file basically, which you can then call in init assets. These are the imports for this video. These are the JBox 2D engine classes, but they come from the same library because they're sort of in the same jar file. So yeah, the source code will be up on GitHub as always. And yeah, so physics test app extends game application. In main we simply call launch. We have our entity types: player, ball, bullet, screen, non-physics object, and platform. So a variety of entities that I want to do a test on. As for fields, we only have a few: physics entity ball, physics entity player. So this new class works like a normal entity we've been working with, except that physics entity supports physics simulation, and I'll show you that in a minute. We then create an entity object, which is just a dummy object, because I want to do a test on collision detection between a physics entity and a normal entity. So it's going to be our non-physics object. And we have a texture, which is the ball texture, which is that one that we downloaded from the internet. Make sure it's a square because it'll be easier to do circle shape to do collision detection. You'll see in a minute anyway. So settings, set title, you don't have to do this just for tutorial's sake. Init assets, the only thing that we're loading here is asset manager.load texture, and then pass the name of the file, and yeah, that's it. It will, as long as it is under assets.textures, FXGL will find it and load it as a texture. In initialize game, we now have an access to a new object called physics manager, which in the future will be managing everything to do with physics and with physics environment. So we set gravity to 0, 0 because there is, as you can see, there is no gravity in this world of ours. So yeah, if there was actually, we can change gravity to 0, 10, and this should enable gravity. Yeah. This green object is the dummy non-physics object, so it is not. There are no forces that affect that object. This thing is controlled. This is the player and is controlled by you. And this is the ball is dynamic object, which is controlled purely by the forces applied to it. So what we have now is, so you can set gravity to anything you want, really. 0, 0 is for those games where you don't want to have gravity, and if you change it to something else, so for example 0, 10 will simulate more or less realistic gravity for, say, platformers or side scrollers, if you want gravity, of course. Next thing we do, we initialize screen bounds, and as you can see, the when you hit the ball doesn't go beyond the frame, beyond scene boundaries and screen boundaries, and those screen boundaries are defined. There are physics entities, one for top, bottom, left, and right. So we essentially create lines, thick lines around the screen, and the physics entity is of type screen. So essentially, the way you create a normal entity, or the way we used to do it, physics entity has exactly the same constructor. It will take a type, an entity type, and in this particular case, it's a type screen. We then set position to 0, -10. That is in x direction 0, so we'll start from there. -10, we'll put it on top of the screen, so we don't actually see it. We then set graphics a rectangle, which will occupy the whole width of the frame, and it will be 10 units in its height. By default, a physics entity is created as static. And I should probably mention that in JBox 2D there are 3 types of physics entity or body types. So you have static, dynamic, and kinematic. Static objects or bodies are essentially non-movable or non-moving objects like platforms. Then you have dynamic, which is, in this case, is a ball. So the ball is a dynamic object in the scene. It moves, all the forces that are applied to it, taken from the environment or from other objects, basically decide how the dynamic object will move. Kinematic, in our case, is the player, which is the black rectangle. And kinematic objects are moved typically by the user by setting their linear velocity. And before I start talking about physics, I should give you a little heads up. I'm not a physicist, nor am I a mathematician. I learned this stuff mainly from games programming, so some of the stuff that I talk about may not be true for real physics, but it will work in sort of game programming. And yeah, so if I move this to 0, 0, you'll see the actual rectangle, which is the static object at the top. We simply move it behind scenes so that it will, with height 10, it will reach the beginning of the screen. This way you can sort of make sure that an object doesn't go off screen and stays within the screen. Same thing for bottom, left, and right. Yeah, the bottom is, we set position to 0, get height, so it'll be positioned right here, bottom left corner with using width of the scene and 10 as the height. Similarly, we do left and right entities, or physics entities, which are right here. And finally, we add them to the list of entities. This here, if it was a normal entity, you would add it to the list of entities so that it does, so that FXGL collision detection system can work, and so it could be rendered to the screen. But for physics entities, there is an extra step that is done behind the scenes. The add entities method will also add the physics entity to the physics simulation world. So basically it will start working as an and controlled by the physics engine. So basically that means that you have to initialize most of the stuff before you add the object, add the entity to the list of entities. And we'll cover this in a minute. So that's for init screen bounds. Now we have init player, initialize player, new physics entity type player. That's something that we were already familiar with. Set position 100, 300 is right here. So the player is positioned right there as a black rectangle. Set graphics rectangle 40 by 60. By default, the rectangle color will be black. The only thing that is different from our previous tutorials is that this set body type, in this case, we set it to kinematic, so that we can control it ourselves. We can set velocity, and by setting velocity, we can change sort of how the object moves. And there is no collision between a dynamic object and a static object. As you can see, it can go off screen easily. Set use physics, that's FXGL's collision detection. So we do this so that a physics object and non-physics object could collide. So we're kind of mixing the two subsystems, the FXGL ones and the FXGL's collision detection system, and JBox 2D's engine's collision detection system. Yeah, we'll get to it in a minute as well. Then init ball. So physics entity can be defined with only a few properties. However, it is possible to do more advanced stuff, and this can be seen from initialize ball. Instead of, I should also mention this, that by default, when you set graphics and then you add the object to the list of entities, the physics entity will be, it will have a rectangular collision shape determined by the width and height that you pass as the graphics. So it could be an image. You don't really have to pass just a rectangle. So if you pass an image, which is a texture, the texture's width and height will be used for collision shape determining. So do not make textures, or do not use textures where the actual object only occupies part of the texture. Otherwise, you'll get sort of very early collision detections, which you don't want. And yeah, you probably want something else if you want to have such textures. So this was the simplest case, pretty much, of creating a physics entity. And as for the ball, I tried to sort of add various different values that you can change, different variables. So fixture definition and body definition are the two things that you can change for a physics entity if you want the entity to behave in a slightly different way. Restitution is the elasticity or the bounciness. So if we change that to 0.1, you will see that the ball will not be as bouncy. Yeah, it will bounce off, but it will drop its speed significantly. And if we change it to 1, then there will be almost no speed drop, so it'll just keep bouncing. Yeah, there's probably no speed drop whatsoever. So 1 probably means to keep 100% of the speed that you had. But the good thing is you can tailor those values for your game or for your applications and just see them how they perform. This is this is how most of the games physics are done. Just making it feel better rather than actually trying to simulate physics. Density allows us to do things like rotations, so the ball will rotate when it hits when it bounces off. So if the density by default, I think it's 0. Yeah, it is. So if we put a 0 in there, then the ball doesn't really rotate, simply moves as it is. So this is somewhat a good value. Again, you can change those values the way you want. Then we have a shape for the picture definition, and this time we choose sort of our custom shape, which is circle shape. And again, this comes from a package called Shapes from JBox 2D engine. You can read its documentation if you want to use your custom shapes. And then we set radius 30 because we change our ball texture to be of width 60 and height 60. And width and height meaning diameter, because width and height of a circle is the diameter, really, and radius is half of the diameter. But the most important thing here to note is that in FXGL and in JavaFX we have always used pixels. The physics engine uses meters, so in order to convert one value to another, you will need to use one of the static methods from Physics Manager. So if you want to convert pixels to meters, then you use 2meters method, and you can use the pixels method to convert meters back to pixels. The thing to remember whenever you're dealing with physics engines, classes, and methods, they expect you to provide an argument of the value in meters rather than in pixels. And FXGL and JavaFX will expect you to provide values in pixels. So yeah, we set the texture width and height to be 60. In this case, with the player, we set the body type directly by doing set body type kinematic. You can also create a body definition, which is body def class from JBox 2D, and then set its type to dynamic. And there are also certain things that you can change, like does it start out as active, allow sleeping, or the angle, the rotation angle when the object starts, its position. But generally, I would suggest doing it this way, our entity sort of related way. so that the API is more or less similar. We create physics entity type ball set position. Yeah, you must do this stuff before you add entities, because this will create an actual body in the physical world, in the physics world. Set graphics ball texture, set fixture definition. This is the FD, and body definition, body def. Since we've already done that, so we set the body def type to body type dynamic, there is no need to call set body type method. But you will need to call this if you want to change it, because by default it's static. And this way we've created a dynamic body physics entity, which is the ball, and which is still rolling. Anyway, so init dummy is the green object, which is that one, and this is our normal entity from FXGL. We create graphics for it, so the rectangle 40 by 60, colored green. It is of type non-physics object. This could be anything. It is just a test for the tutorial purposes. So set position, set graphics, set use physics, so that the collision detection is on between this object and some other objects on which you called set use physics. Finally, we add it to the list of entities. And this is init dummy, and these methods go pretty much one after the other. And platform is that thing, which is right in the middle somewhere. Physics entity platform, new physics entity type platform. We haven't set body type, and we also haven't set body definition, so by default it will be a static body. Platform set position, set graphics, and the physics engine will use this graphics sort of definition graphics node and will retrieve its width and height and then use it as a rectangle. So this is our platform, and because it's static, it will also trigger collision between dynamic and static. So if we try to move the ball near the platform, it will bounce off the platform. It won't go through it. However, it will go through the green object, because the green object is not part of the physics world. What else? So yeah, we've got that. Now we're initializing our collision handlers between type player and non-physics object. So this is how we can do collision handling or collision listening between a physics entity and non-physics entity. So if I open the console, if we move closer to the green object, there will be a collision, yeah. And the collision says, or the collision handling does this. It just prints type as string of P. P is the player, because this is the first type that we passed. Therefore, this is the first type that we get, first object. Collided with, and this type. So type player collided with type non-physics object. Player and the ball, this is the collision detection or collision handling between two physics objects, like real physics objects. Yeah, and we hit the ball and we get a collision. So there's also bullet type that we can, we can also shoot, and shooting happens in init input. So yeah, I'll come back to shooting. This is sort of a test to see that the two. So the object, if you remember, is the non-physics object, just a normal entity, and player is a kinematic physics object. So you can use, if you remember, we use the translate method to move an entity. So 5, that would be in x direction, 0 in y direction. So moving to the right. Calling translate on a physics entity will do nothing because it is managed by the physics manager and in turn by the physics world. So what we can do is set linear velocity, and this will then trigger its move action. So I tried to make it sort of a one-to-one mapping so that when you translate by 5 units, it is similar to setting linear velocity to a new point to the 5 units as well. And in an update, so don't worry about the mouse pressed. Currently, there will be it won't be pressed, so this will keep setting the velocity to 0, 0, which means it is non-moving object, so it will not move. Because if we don't do that, since it's a kinematic object, once we've set the velocity, it will continue moving at that velocity without stopping. So we have to do this in order to stop the object. So this is a key press binding on key code D. So if I press D, the non-physics object will move and physics object will move. And as you can see, they move at the same speed, at the same velocity. So we're translating non-physics object at exactly the same speed as we're setting the linear velocity to a physics entity, physics object. And this should help you deal with speeds better, because you cannot move a physics entity by using translate on it. Similarly, said translate methods will not work as well. They just won't do anything. And on key type binding F, so if we press F, we shoot. And this is another test for the bullets. So if I press F, a bullet is fired, which is essentially a rectangle. And because it's a physics object, because it's a physics entity, they will interact with other physics entities. As you can see, if we hit the ball with a bullet, it will sort of will be bounced by the ball, while the ball will acquire some of the speed, some of the velocity of the bullet. So what we do is we take the mouse X and Y, so where the cursor is on the screen. We then subtract a player's position, which means we obtain a vector, which we then multiply by this value to make the velocity smaller, because in pixels it will then be multiplied by a greater value to get to meters, so you'll still get decent speed. That's an interesting fact. The bullet didn't hit the screen, but hit another bullet, and hence it's on the screen. Okay, so we create the bullet. So this is the velocity. We simply store the velocity. We'll need to use, we can use the velocity to obtain the angle we need to rotate to the object. Set graphics, new rectangle, 10, 1, fixture definition, we now set density to 1 so that it can do the rotation thing. Without that, it won't rotate properly. So just continue going. And won't be as bouncy. So essentially you can do whatever you want with those values, as long as you can get the right effect for your current game. Now that we've defined our fixture definition, we need to set it to a bullet. We then create body definition. We set bullet to true. This is the stuff that allows, this flag allows the physics engine to know that this is a bullet, so we don't sort of make it go through objects, but do a tunneling sort of almost like raycast collision detection. So because bullets typically travel at high speed, it may go through an object and there will be no collision fired if the bullet's speed is greater than the object's collision shape. So hence we do we set this flag to true. The angle with which we need to start is we can obtain it from the velocity. From the velocity vector, we call a tangent with velocity get y and get x. Because in physics engine the y-axis is inverted, so 0, 0 is actually in the top left corner, not bottom left corner, not the top left. In window toolkits and graphics toolkits, we usually see that top left is the 0, 0 coordinate, and this is why we need to negate the angle. Or you can do it with negative y coordinate. Finally, we set the type to dynamic because the bullet is dynamic, and we set by the definition. You can set it to kinematic if you want to, but that would mean the bullet's speed will not change, will not alter, and you'd have to modify it manually. And if it's an arrow, this is something that you might want to do because the arrow is slightly different than a bullet. We might do another tutorial where you can shoot an arrow from the bow and sort of get this real arrow physics. We then finally set position to, we get player's position. We then add 20 and 30, so we add this vector, which gives us a point which is in the center of the player, because player's rectangle shape is 40 by 60. There it is. So we get half of it, and because get position returns top left corner of the object, by adding this we get to the center, and we then add we normalize the velocity and multiply it by 40 because so that this is greater than the largest value, so the bullet will spawn outside of the player with correct direction. Otherwise, because the physics entity player is a kinematic object, it will collide with the bullet being shot from inside the player, which is not something you would like to have in your game. Once we've defined our physics entity, we add entities. Another thing to note that we cannot set linear velocity before we added the object, the entity, to the list of entities. Otherwise you'll get an exception, because you'll first need to spawn the body in the physics world, and only then will you be able to apply linear velocity. However, this stuff must be done before adding to the list of entities. So it's kind of very strict when it comes to physics engines. What else? Oh yeah, the last thing, mouse left pressed. This is the on update, which is the update tick that happens 60 times a second. If left pressed means if left mouse button is pressed, then we set linear velocity to player. We obtain the XY of the mouse, we subtract player's position, and then we finally multiply it by 0.1 so that it doesn't immediately have this velocity. So it sort of slows it down a little bit. And this creates this effect of the object or the entity following the cursor. It's kind of smooth and really nice. What else? I think we've covered all of it. Well, when the bullet hits the screen, remove the entity bullet. And when bullet hits the ball, we could remove it, but this... yeah. So now when we hit the bullet, or hit the ball with the bullet disappears. We remove the entity. You remove the entity and add the entity as usually, using the same method as for normal FXGL entities. Now, although I've demonstrated the collision detection between non-physics and physics object, I wouldn't recommend mixing them, because the FXGL collision is based on the JavaFX collision mechanism, which is a bounding box, and this might fire before the physics engine's collision detection happens, which means that you might remove the entity before the actual collision, and that would mean that an object will fail to interact with another object in physics world, and this is pretty much the only disadvantage. But it still really depends on what kind of game you're developing and things like that. You can play around with values, and there are quite a lot of values that you can modify and see if one value works better for you than the other. Most of the stuff that you'll be doing will not involve using a physics engine. So for example, platformers, you wouldn't do a physics engine for the actual game logic, but still you could use physics engine for stuff like rope swinging, water effects, particles, and stuff like that, which we will cover eventually. And yeah, so this is it for this tutorial. In the next tutorial, which is tutorial 29, we'll do QuickTime events, which is a new feature in the latest version of FXGL. If you have any questions, you can email me or just write a comment. I will get back to you as soon as I can. And yeah, thanks for watching.